Okay, so today we're going to be doing a calculus free response problem from the 2007 AP, and this is problem number 1. So the problem says, let R be the region in the first and second quadrants bounded above by the graph of y equals 20 divided by 1 plus x squared, and below by the horizontal line y equals 2. Okay, so part A says, find the area of R. So you have these two functions, y equals 20 divided by 1 plus x squared and y equals 2. And it tells you in the problem that that y equals 20 divided by 1 plus x squared is the top function, and that y equals 2 is the bottom function. So if you were to graph these two functions, it would look something like this with, again, y equals 20 divided by 1 plus x squared is the top, and y equals 2 is the bottom one. And area R looks something like this. It's the area bounded between the two functions. So in order to find this area, the formula is the integral from a to b of top minus bottom. Okay, and so, like I said, your top function is 20 divided by 1 plus x squared, and the bottom function is 2. And in order to find a and b, you have to find the place where these two functions intersect, because that's where the area, that's the limits of the integral. So you would plug into your calculator these two functions like you did earlier to graph it, and click on F5 if you have an 89 calculator, and go to intersection points and find those two intersection points. So in this case, these two intersection points are -3 and 3. Or A is -3, B is 3. Yeah. Okay, so then you're going to want to put in all of this information into your formula that you had. So the top is 20 divided by 1 plus x squared, and then the bottom is 2, so minus 2. Then you plug in your limits, a and b. And so you put this into the calculator, and you should get the answer is 37.9618, or somewhere around that. Okay, so part B asks you to find the volume of the solid generated when R is rotated about the x-axis. So, to find this, the formula that you would use, the volume formula, is pi times the integral of R outer squared minus R inner squared. And in the R outer, you do top minus bottom squared, and then R inner you do top minus bottom squared. And because it asks you to find it when it's rotated about the x-axis. Also, that, by the way, that's the reason that you have the pi there, is because it's rotated. So because it asks you to find it, find the volume when it's rotated about the x-axis, you have to include the x-axis into these formulas. And so in each of the R outer and R inner, either the top or the bottom will be 0, because that's the horizontal line that the x-axis makes. So you have to figure out, based on the graph, which we looked at earlier, whether or not these two functions are above or below the x-axis, because that'll determine whether the x-axis is the top or the bottom. And for both of these functions, the x-axis is below, so that'll be the bottom. And so you have to do R outer, which is the function that is furthest away from the x-axis, minus R inner, which is the function that is the closest to the x-axis. So in this case, once again, the top or the outer would be 20 divided by 1 plus x squared, and the inner or the bottom is y equals 2. So you're going to go ahead and plug that into your formula. And so you do top minus bottom, which makes up the R outer, and then square that, minus top minus bottom, which makes up the R inner, and square that. And make sure you keep your same limits, which would be -3 to 3, And you have to make sure that you multiply it by pi because you are finding the volume and it's rotated around the x-axis. And when you plug that into your calculator, you should get that the volume is 1,871.91 or something like that. Something pretty similar, hopefully. Okay, on to part C. Woohoo! Almost done. Part C asks you it says, the region R is the base of a solid. For this solid, the cross-section perpendicular to the x-axis are semicircles. Find the volume of this solid. Okay, so if you remember, the area of a circle is 1/2 pi r squared, and that's important to remember when like figuring out the formula for this to find this volume. And so, yeah, to find this volume. Okay, I was right. So to find if the cross section, if there were circles, it would be pi times the integral of 1/2 times top minus bottom and all of that squared. But because it's semicircles, which is half of a circle, you're going to divide pi by 2. And that should be right. And so you still use your top minus bottom, and the top minus bottom part is what makes up the radius. So if you're wondering where that part is incorporated, you use your top minus bottom, and it's still the same. The top should be 20 divided by 1 plus x squared, and the bottom should be 2. And so you make sure you square all that and divide it by 2. And then also remember to multiply the whole integral by pi divided by 2, and you use the same limits, which are -3 to 3. And then when you plug that into your calculator, you should get 174.268 or something like that. And yeah, I think that's it. Okay, I hope you guys understood. Thanks for listening.